I'm Don Laboriel from QuickSilver Controls, and I'm going to cover CANOpen communication types and operations. First, the message types are divided into network management, NMT, service data object, SDO, and producer data object, PDO. The PDOs are of two flavors: receive PDOs and transmit PDOs. All the contents are managed using a structure called a data dictionary. Network management messages are able to reset or change the active status of nodes. And resetting actually force a hardware reset to fully reinitialize the node. You can initialize just the CAN portion. After initialization, they default into what's called a pre-operational state, in which NMT and SDO packets are available. They can be transitioned to an operational state in which all communications are available. And finally, if there's a fault, they dropped into a stop state, which shuts down the PDO operations, so allowing NMT and SDO. The NMT messages are also used to report any changes in NMT state, and both on a live basis, and you can set up a heartbeat, which will go through and do it on a periodic basis, so you can note it if a node has dropped out of operation. The NMT packets are all unconfirmed, meaning no one responds to the packet. SDO data objects, on the other hand, are confirmed. A write command, a transmit command across SDO is acknowledged back with a acknowledge, or with a no acknowledge, with a negative acknowledge, if the operation being asked was not able to be done. Either the data dictionary object did not exist, or you're trying to do an illegal mode of operation, such as writing to read-only. These are single events. Each time you want to go through and read or write, you have to cause these to happen again, but they can contain multiple data. Typically they're single frame, which is up to 8 bytes, but they can be chained to handle larger data frames, such as the ASCII frames associated with model, make, and name. These are also used to go through and configure nodes via CAN. They're one-to-one connection, and you have to set up the connection before they're used. Finally, there's producerated data objects. These are unconfirmed. They're broadcast from the transmit node, and none to as many as our nodes on the bus can be configured to absorb the data, to consume it in the vernacular they use. Data is broadcast by the source node and is set up to be broadcast on a regular basis, either time-based, based on synchronization, or based on change of the data. Here's a PDO example. We have node 17 transmitting his input register. So when any of the inputs are varied, whenever they change, we automatically generate a frame. And we normally set it to also transmit a frame on a periodic basis, such as every 20 milliseconds, which is useful if you're monitoring the bus. You do not have to have seen the original transition. Node 16 is set to map that data into register 199, which is useful for doing various compares on a bit basis. And this just runs in the background. You configure them once, and whenever an input on 17 changes state, they'll automatically be reflected in register 199 on node 16. Data dictionary. This is the structure defined under CANOpen that allows common naming of data, identification of data type, and complex data sets. So you can either use elements, array of elements of the same type, or structure different elements to configure different portions of the system. NMT standard objects. The heartbeat allows a node to monitor other nodes for change in status and for continued operation. They do this by sending their NMT state every so many milliseconds, with changes being sent immediately. The monitoring nodes can monitor up to 8 other nodes and can set to automatically trigger a kill motor condition, or they can poll within their operation to see if any of the other nodes have changed out of operational state. An excessive time since the last heartbeat, a timeout of the heartbeat, will also go through and trigger a fault. And the heartbeat's intentionally set as a low priority message. So if it's continuing to being received, the whole network is working, it's not overloaded. If the heartbeat starts being delayed, it's an indication that too much data is trying to be sent across the network. And again, it will go through and trigger a fault either by pull or by kill motor. For information, see our website, www.quicksilvercontrols.com.